Welcome to part 2 of the moon talks, or whatever you want to call it. This little section will include a few simulations from a cool little website called astro.unl.edu. And all these little tabs we're going to look at. These are eclipses that occur year by year, 2000 through 2025, 26, 27, 28, 29, through 2029. Let's take a look. The gray ones are lunar eclipses. The yellow ones, of course, are solar eclipses. I'm going to click on this one. Take a look. A solar eclipse. It lasts 2 minutes and 47 seconds. Look right down in this area. 2 minutes and 47 seconds. This one, 4 minutes and 9 seconds. This one, well, 44 seconds. Remember in the lecture notes when I showed you how small the umbra of the moon was? One, it has a small umbra. Two, the moon is moving around the Earth. And three, the Earth is rotating. So the total length of blockage of the sun is really short for a solar eclipse. Take a look. Do we get to see any of these in the United States? Nope. 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 Kind of sad. Let's look at the lunar eclipses for comparison. That doesn't give as much. Take a look at the length of this one, the duration, 3 hours and 23 minutes. Earth's umbra is big compared with that of the moon. And I don't have anything else to say, just thought I'd say and. I have no idea why they aren't listing the durations for those. Oops. Okay. Just kind of cool. You remember this picture earlier? Here's the Earth, here's its umbra, here's the moon in our umbra. In this case, this is a lunar eclipse. Again, everything isn't to scale. If we are this close to the sun, we'd be burned up, or it would be extra cool. Let's move the moon around. Oops, come on. Don't be shy. And notice no matter where I move it, the shadow moves away from the sun. So I'm going to move it right here. This would be an annular eclipse. There would be a total solar eclipse, but only for this place on Earth right there. It's going to be a very short event, again, as the moon is moving and as the Earth is rotating. Oops, sorry, rotating. Let's get the right direction there. I think we're done with that one. Tides. Here's the sun over here. Turn the sun on, and you end up getting a shadow on the Earth, and you end up exaggerating what's going on. And let me drag the moon around. Let's see what happens if we just include the moon. Here we are rotating around. You know what? I'm going to reset this. Here's the United States. We're at midnight. Let's go through one day. There's sunrise, noon, sunset, and midnight again. Missed a little bit. Notice we went through a high tide, a low tide, a high tide, and a low tide, and a little bit less. If the moon were the only thing out there, we would go through 2 high tides and 2 low tides about every 24 hours and 50 minutes. Again, the extra 50 minutes because the moon is moving around the Earth while the Earth is rotating one time in 24 hours. But this isn't the way it is. You know what's wrong. We're missing a large object in the sky. Let's go back and include the sun. Watch what happens to the level of the ocean here if we include the sun. Whoa, it gets pulled up extra high. And on the back side, it's extra high. So when we rotate around, you're going to have a high tide, a low tide, a high tide, an indirect high tide, and another low tide. And then as we come back around, the moon will be here, so it'll take rotating from here over to here to get back to the next high tide. Let's run it. Just watch for 1 month. look what's happening to the height of the high tide. It's decreasing. The high tide is no longer really high, and the low is no longer really low. But fear not, after about 14 point something days, we're back to really high tides and really low tides. Why? The sun and the moon are pulling in, well, they're kind of in agreement, even though they're on opposite sides of us. Okay, let's do this again. This was a spring tide. This is the first quarter, and it leads to a neap tide, a low high and a high low. Right here, we are getting to the waxing gibbous. Going to see it overhead at 9 at night. We're going to come to the full moon. Going to see that overhead at midnight. Even though, to be honest, you can see the full moon from anywhere on this side of the earth anytime at night. Notice again, we are at a really springy tide. We had a spring tide over here, spring tide here. I know I'm going on, but I want you to get this because you're going to see it again on the quiz. You go back to a neap tide, not very springy, and you get the idea. Next simulation. Let's make sure you know these things. The new moon is when the moon is between the earth and the sun, but it's above the plane of the earth and the sun. You really can't see it in the daytime. Go out and look for it. Don't stare at the sun, that's bad. Waxing crescent, this is one of the best times to look at the moon. You're going to see this early in the morning or just after sunset. Now if you lay with your head toward the north, on the ground, no kidding, and tilt your head left and right, you're going to see this one right after sunset, and the sun is going to be on the right side of the moon. When the light is on the right, the moon is gaining might. When the light is on the left, the light is leaving where it has left. Okay, once again, new moon, waxing crescent, first quarter, waxing gibbous, full moon. Now why am I going through this so quickly? You're going to do a lab on this, so it's not really a big day. Sorry, not really a big deal. Now notice the image of the moon itself isn't changing. Why? The moon keeps the same side of itself toward us. We never see the back side of the moon unless we take a long walk and go behind the moon. The Russians have done that. The US has done that. I believe the Chinese have gone back there, but not you and me. Next one. This is what things look like from the Earth. Here's a full moon. Watch what happens as we go through a month or a month. Oops. This is what the moon looks like from the Earth. This is just so cool. It's similar to the animation that you guys are going to use for your lab, so no biggie. You'll get it. This is one thing that I wanted to show you about the moon and the Earth not being in the same plane. Let's say the sun is over here, coming from this direction. Here's the Earth, and the moon goes below our plane and above our plane. So very rarely does it actually come in line with the Earth and the sun. Watch what happens to the tilt of Earth's sun, or the Earth's sun plane, compared with that of the moon. Okay, I'm going to advance this a little bit. Enough of that. The difference between a sidereal day and a solar day. Let's do a sidereal day first. Let me reset this. For the Earth to go around one time, let's say we have a really tall flagpole here, and we want to go around 360 degrees. Let's do it. We just went around 360 degrees. But is the sun overhead again? No, it's not. Why? Because we've moved about 1 degree around the sun. What has to happen then? We have to rotate another, almost 10 degrees to get back in line with the sun. Now, yes, that was actually about 10 days worth of motion, but you get the idea. We're going to reset this. Now let's do one more. Take a look what happens if we use a 360 degree measurement as our day. We're going to be way off. Reset. Let's look what a solar day is. A solar day is actually way more than 360 degrees. Here's our flagpole. Watch really quickly. Cool. I don't think we need to mess with this one and the last one. Here we go again. Let's see if you guys can name the phases. You know what? Let's not, because you're going to do this during the lab. I'll just stop here, and you guys have a good time. Get on with your study sheet and your lab. See ya.